Good day, everyone. I am Frederic Salimi. I am the director of PMCO Pro. Today, I would like to show you how we customize a safety concept for your project or for your installation. So let's start. What is objective of safety concept? The purpose of safety concept is to ensure that the risk to life, the environment, and asset has been rendered either tolerable or reduced to alarm. Alarm means as low as reasonably practical level. Safety concept specifies measures to avoid exposure to potential hazards, minimize the potential for hazardous occurrence, contain and minimize the consequences, provide means of escape and evacuation, and ensure that all installations are designed to safe standards and also provide a safe working environment for site personnel. In safety concept, there should be a brief description about principle of inherently safety. That is the first priority that any installation or operator should pay attention. One of the topics of principle of inherent safety is intensification. It means that try and minimize the quantity of hazardous substance. Substitution. Try and replace each hazardous material with a less hazardous alternative. Attenuation. Using less hazardous condition, especially avoiding any condition under which materials become more hazardous. Limitation of effects. Design facilities that minimize the impact of the release of hazardous material by providing separation between plant, storage area, and process trains. Simplification, design facilities that makes operating errors less likely. Try and make operation intuitive. It should be easy to do the right things and difficult to do the wrong things. Error tolerances, design the facilities so that even if someone does the wrong things, a hazard will not result. So I give you an example of inherent safety. For example, if the pipeline to well is fully rated, it is a principle of inherent safety was applied for the project and should be recorded in safety concept. So now I'm talking about the update of the safety concept. During each phase of the project, all safety-related documents prepared during the previous phase shall be reviewed and updated where required. I give you an example. Normally, for example, in the feed of any project, front-end engineering, there is a safety concept will be developed. This safety concept shall be developed, updated in detailed design when the layout plot plan changes, and it should be issued at that stage. And it should be at earlier stage of the EPC phase, because this is a document that all the there are the decisions of the project about the active protection, passive protection, everything in this document should be updated, and the project follow instruction that given in safety concept. Uh, One of the things is should be modified in safety concept is, for example, explosion calculation. Explosion calculation depends on the congestion, the layout of the installation, and it has an impact in plot plan, in fire zone, safety distance, restricted area, emergency protection. So these are the things that should be for uh, update of the safety concept. Handing over the safety concept, at the end of the project, the safety concept shall be handed over to company for few months before a startup. Safety concept shall constitute the main document to ensure safe operations during entire life of installation. So this is very important. And the following reflect applicable law, regulation, safety-related project documents, company specification, international code and standards, and derogation. Now I give you the table of content of safety concept. A safety concept shall cover a brief description of facility description. A brief description of hazard classification review like hazard, seal allocation. Safety assessment studies, for example, drop object studies, ship collision for offshore installation, etc. Technological risk assessment. There should be a brief description of PRA. PRA means preliminary risk assessment. Should be there. DRA is detailed risk assessment. These are the scenario-based analysis. QRA is quantitative risk analysis. Bow-tie analysis means that define the barriers for prevention and control and mitigation and escape. Risk reduction, and finally alarm demonstration. There should be these topics, very brief description in safety concept. Safety and environmental critical element. The list of the safety critical system and subsystem should be given in the safety concept. Layout philosophy. Should be a brief description about layout philosophy. For example, the safety, for example, if you took into consideration wind direction, where goes the flammable gas and how you put it in the how you optimize the layout of the installation based on the result of dispersion calculation, etc. ESTV location, for example, if EST location is outside of the fire zone, that means if any explosion fire happens in that fire zone, ESTV is far from that area and can work its function. If it doesn't work, if it is inside the area, it should be passively protected by PFP, and that affect the functionality of ESTV, and it should be mentioned in safety concept. Fire zones. Fire zones is normally we divide the installation in different fire zones, and these fire zones, that means if there is any fire and an explosion in this fire zone, it will not impact on the other fire zone. For example, one of the example is process area in a unit. It can be a fire zone, and utility area in other area. There are other fire zones. That means if something happening in your process area, it will not impact your utility area. Restricted area is a maximum distances that, for example, gas clouds or explosion goes in the installation, and that will be requirement for the definitions of the fence in that area. And also, if there is a building in this restricted area, that means the gas can go in that area. So the HVAC intake of that building shall have the fire and gas detection with the required executive action. Impacted area is those areas that goes beyond the installation, and there should not be any public building, etc. to be there, even if they are almost safe, but the people can be impacted, the public can be impacted, and should be in those areas. So we will discuss all of these topics in our customized training when we see your installation, and we discuss this and we customize the training course. Safety distance is important between the installation, between units, etc. What is the safety distance? Hazardous area classification, this defines the type of electrical equipment. Shall they be attacks? And also define that if the building is inside this hazardous area, and they should have airlock, that to prevent the gas goes inside the building, or HVAC intake, yeah, the required gas detection and closure of the dampers in case of the confirmed gas detection. So this should be also in the safety concept. If there is any specific hazards that specific for the project, it should be mentioned. Emergency shutdown system, that should the level of emergency shutdown, for example, if there is EST1, EST2. EST1 is total blackout, you isolate all the electrical equipment, but EST1, EST0, EST1, EST3, each project has different definition of the level of EST and should be written in safety concept. Emergency depressurization, what is the how we depressurize the system? In case of the confirmed fire and gas detection, do we do depressurization? If the depressurization is for the whole plant or if it is for the fire zone. So these kind of things should be discussed in the safety concept. Failure and vent system. There should be discussion about the failure and vent system, particularly the vent. For example, the vent also create the gas relief, and all of this. The system should be specific, and brief description of that should be given in the safety concept. Terrain and spillage management. This is also important, that how we, for the drainage, for example, open drainage capacity of this. If, for example, if there is a fire in that area, deluge system will be initiated. What is the volume? What is the autonomy? How we do the separation between the oily water or rainwater. So the drainage and speed management is important, and we will discuss about this later. Fire and gas detection. For example, water and gas detection and executive action, type of the fire and gas detection, especially the threshold. What threshold, for example, if there is 20% of what we call it LEL, lower explosive limit, or 10% for inside the building, this should be discussed. Emergency power, UPS, for example, if there is UPS, what is the autonomy of the UPS? This is also has to be discussed. Escape and evacuation and emergency control facility, the brief description of the system should be given in safety concept. And finally, personal safety. Now I show you how we do it in our workspace. If you get a contract from a project or installation to customize a safety concept, we will create a workspace for safety engineering training. Safety concept is module 01. I click on this, they will have access like this. So we enter in the workspace for safety concept development. So here we have two categories of the directories as a document control. Client training materials. Company we put all they put all the safety related documents in these documents, and then we will create the uh, customized training, like what we do here, for to be distributed to personnel of the company. When it goes, for example, it should be something like this, e-course here. We created here, and this training course will be created for the company after approval, and then we will work on this. When it is distributed to the project, there will be a creating a new discussion, all the company personnel. For example, here, customized training. This is what we put it here. Company personnel look at this training course, e-course, and then here they ask the question. They can insert any file that they have, any links, and they ask question, and the expert of academy will give the required answer for them. So this is the way that we work, and in this workspace, there will be the task management. Basically, we created the task and the web link and document control and the contact of the personnel for development of the safety concept. So now I would like to show you a couple of videos of CSP. CSP is an independent agency in United States with investigating in the industrial chemical accidents. There are several good videos there, and I suggest that you go and see them. I brought certain part of their videos that gives the recommendation about the accidents, and it would be good that all your project or installation are aware of this recommendation. For example, if there is change management, training, customer training, and all of these good informations are there. And I hope that I will have the possibility to customize your safety concept for your project and installation in your future.
The CSB found that lack of winterization procedures also contributed to a massive fire that took place in 2007 at the Valero refinery near Sunray in the Texas Panhandle. The fire occurred in a unit that used large amounts of high-pressure liquid propane. Years earlier, the unit had been reconfigured, creating a dead leg, or a section of piping without any flow of liquid. Dead legs are particularly vulnerable to the hazards of freezing, and the dead leg at Valero was blocked on one side by a leaky valve. These two serious accidents illustrate the importance of establishing effective winterization programs at refineries, chemical plants, and other facilities that handle hazardous materials. The CSB has established key winterization safety lessons that facilities should follow. Facilities should effectively identify and address the risk of freeze-related hazards to piping and process equipment through process hazard analyses, management of change evaluations, pre-startup safety reviews, and operating procedures. Create and implement a winterization checklist to ensure that their plant and process systems are ready for cold weather. Establish a formal written freeze protection program. Survey piping systems for dead legs and ensure they are properly isolated, removed, or winterized. January 22, 2018, the Pryor Trust gas well in Pittsburgh County, Oklahoma. The well was operated by Red Mountain Operating LLC, which contracted the Patterson-UTI Drilling Company to drill the well. In order to change a drill bit, crew members removed the drill pipe from the well. Approximately 3.5 hours later, a blowout and rig fire occurred, killing 5 workers. Within the chemical industry, for the location and design of control rooms, there is no guidance specific to drilling. As a result, the CSB made a recommendation to the American Petroleum Institute to develop guidance addressing the protection of onshore rig workers from fire and explosion hazards in the event of a blowout. The guidance will specifically address the design and location of the driller's cabin and establish minimum required evacuation methods from various locations on the rig.